One of the most things used today is the internet network. The internet network is a network that abarcs all spaces around the world. Today we use the internet for communicate and transmit data about many information, for example, emails, images, videos, and multimedia. The internet was through a packet routing network in accordance with the Internet Protocol, IP, the Transport Control Protocol, TCP, and other protocols. But what is a protocol? A protocol is a set of rules specific of how computers should communicate with each other over a network. For example, the TCP or Transport Control Protocol has a rule that if one computer sends data to another computer, the destination computer should let the source computer know if any data was missing, so the source computer can resend it. Another protocol is the Internet Protocol or IP, which specifies how computers should mute information to other computers by attaching address on the data it sends. Data sent across the internet is called a message. Before a message is sent, it is first split in many fragments, called packets. These packets are sent independently of each other. The typical maximum packet size is between 1,000 and 3,000 characters. The Internet Protocol or IP specifies how message should be packaged. It is a network that routes packets from a source computer to a destination computer. The Internet is made up of a massive network of specialized computer called routers. Each router's job is to know how to move packets along from the source to their destination. A packet will have moved through multiple routers during its journey. When a packet moves from one router to the next, it is called a hop. You can use the command line tool transfer to send the least hops packets take between you and a host. The Internet Protocol specifies how network address should be attached to the package headers. A designated space in the package contains its metadata. The Internet Protocol also specifies how the routers should forward the packets based on the address in the header.
How do the working computers figure out IP addresses based on domain names? We call looking up the IP address of a human-readable domain name like google.com. Resolving the IP address, computers resolve IP addresses through the domain name system, DNS, a decentralized database of mapping from domain names to IP addresses. To resolve an IP address, the computer first checks its local DNS cache, which stores the IP address of websites it has visited recently. If it can find the IP address there or that IP address record that expired, it requires the ISPs DNS servers, which are dedicated to resolving IP addresses. If the ISPs DNS servers can find and resolve the IP address, they query the root name servers, which can resolve every domain name of a given to the level domain top. The level domains are the words to the right of the rightmost period in domain name, like for example, .com, .net, .org are some examples of the top level domains. How do applications communicate over the internet? Like many other complex engineering projects, the internet is broken down into smaller independent components, which work together through well-defined interfaces. These components are called the internet network layers, and They consist of a link layer, internet layer, transporter layer, and application layer. They are called layers because they are put on top of each other. Each layer uses the capabilities of the layers beneath it without worrying about its implementation data. A new router may come with a few pre-configured routes, but it's encountered a packet it doesn't know how to route. It requires one of these neighboring routers. If the neighbor knows how to route the packet, it sends that info back to the requesting router. The requesting router will save this info for the future use. In this way, a new router brings up its own routing table, a database of network prefixes to outbound links. The neighboring router does not to know. It requires its neighbors and so on.
A brief history of the Internet. Cold War was in full swing in the 1950s, and the US was worried about the Soviet Union growing scientific progress. Because of Sputnik 1 launch in 1957, the US military was concerned about the Soviet Union attacking from space and destroying the US long-distance communication networks. The excited National Defense Network relied on telephone lines and wires that were susceptible to damage. In 1962, agencies from ERPA and MIT used connotation computers to keep communication networks activated in the use in the event of nuclear attack. This network came to be known as the ERPA network. On ERPA-net packets switched and made data transmission possible in 1965, and by 1969, military contractor both Bernet and Naval BBM developed an form of routing device known as interface missile procedures, which revolutionized data transmission. The Stanford University network was the first local area network containing distance workstations. In 1981, the NSF expanded the ERPA net to National Computer Science Research. When it founded the Computer Science Network, began assumed computation managed in 1984. ERPA-net adopted the Transmission Control Protocol (TCP) in 1983 and separated out the military network (MILT)-net, assigning a subset to public research. Launched normally as the National Science Foundation Network in 1988 and 1985, engineers designed it to connect university computers inside departments across the U.S. ERPA transitioned to the Open Network Protocols (TCP) and EP in 1983, accelerating the already burnout spread of Internet working technology. Cites Stephen Ward principle with Internet 2, when NSF and Fleeting adopt the same protocols, and ERPA-net technology spread rapidly, not only to university computers across the USA to support the higher education community, but also the emergent Internet service providers to support commerce and industry.